Hi students, welcome to Diamond Group of Institutions NEET and K-CET online classes. Okay, today we are going to discuss about the electrostatic potential and capacitance. Here also we will discuss all previous year's questions only. So concentrate on this one. You will get one idea what type of questions are asking in the exam. Okay, now see the first question. In free space, a particle A of charge 1 microcoulomb is held fixed at a point P. Another particle B of the same charge and mass 4 micro kg is kept at a distance of 1 millimeter from P. If B is released, then its velocity at a distance of 9 millimeter from P is. Okay, this is the question. See now what they given. First, A charge is a particle ka charge is 1 microcoulomb. Okay, it is fixed at the P point. Okay, next they are taking the one more charge. B, it has the same charge like A, so that is also 1 microcoulomb, and mass of this one is the 4 micro kg. Okay, na? Okay, that means 4 into 10 power minus 6 kg, and first it is released at one distance, is released a distance of 1 millimeter from the P. So initially this B particle at 1 millimeter distance from the P, at this point it released, this is the positive particle, this is also positive particle, repulsion takes place, it will move away from this one. Okay, then it reached to the 9 millimeter. Okay, na? From P point the given distance 9 millimeter, then what is the velocity of the particle? If B is released, then its velocity at a distance of 9. At this 9 millimeter, what is the velocity of the B particle we have to find. So here we have to use the conservation of energy principle. So now whenever the particle B is 1 millimeter distance from the A particle, then what is the potential energy between these two we have to find. So potential energy formula already we know. So potential energy symbol U or P, whatever it is. So K into Q1 Q2 by potential energy formula. Now whenever it is at 1 millimeter distance from the P, then the potential energy between the A and B is K into QA into QB by R1, initially 1 millimeter. So K value is 9 into 10 power 9 into QA value 1 microcoulomb, 10 power minus 6, QB also 1 microcoulomb, 10 power minus 6, by distance between these two is nothing but the 1 millimeter, that is the 10 power minus 3 meters, 10 power minus 3 meters. Now this 10 power minus 3 go upside, 9 plus 3 12, this minus 6 also minus 12 plus 12 will be cancelled, we will get the 9 joule. So whenever the B particle at 1 millimeter distance from the P, then it has the potential energy 9 joule. Now it reached 9 millimeter from the P point, it reached from here to here, it reached, so distance from the P is 9 millimeter. Whenever it is 9 millimeter distance from the P point, then what is the potential energy we have to find. So potential energy in the second case, K into QA Q by R2. K value is 9 into 10 power 9, charges both are same, 10 power minus 6 into 10 power minus 6, R2. Now the charge B at the distance 9 millimeter from the P. Okay, 9 into 10 power minus 3, simplification we will get the 1 joule. That means potential energy decreased. Okay, initially 9 joule and finally 1 joule. So whatever the energy decreased here, that energy is converting into the kinetic energy. That means here due to the repulsion force it is getting velocity, na? So this potential energy is converting into the kinetic energy. So we have the, from the conservation of energy, change in potential energy equal to the change in kinetic energy. So final kinetic energy minus initial kinetic energy is nothing but the 1 joule minus 9 joule minus 8 joule equal to the initially here velocity equal to 0, initial kinetic energy is 0, final kinetic energy we have to Kf minus Ki, initial kinetic energy equal to the 0. Then substitute here, change in the potential energy equal to change in kinetic energy. So 9 minus 1, 8 joules, change in the potential energy is 8 joules, initial kinetic energy is 0, so final kinetic energy is of mass of the B particle and velocity of the B particle. Okay, so now Vb square equal to the, we have to find the velocity of the B particle, 2 send this side, 8 into 2 16, mb send this side, it will become denominator. Mass of the B particle is 4 into 10 power minus 6, 4 into 10 power minus 6. So now 4 ones to 4 fours we will get, 4 into 10 power minus 6 send upside, 4 into 10 power plus 6 we will get, and Vb equal to how much we will get, square root of 4 into 10 power 6, that is 2 into 10 power 3 meter per second. In this way solve the problem. Very easy question, last year mains question. Next, the electric field in a region is given by E equal to the Ax plus B I cap, where E is in Newton per Coulomb and X in meters. So the value of constants are A equal to 20 SI units, B equal to the 10 SI units. Okay, na? A value they given 20 SI units and B value they given 10 SI units. These are the values given. Okay, if the potential at x equal to 1 is V1 and that at x equal to minus 5 is V2, then V1 minus V2 is V1 minus V2, we have to find potential difference. Okay, now we know the relationship between the potential and the electric field. So that is nothing but the dV equal to the E minus dx, otherwise E equal to the dV by dx we know. So from the dV equal to E minus E into dx. Why we are taking negative also, I said in the previous class, that is nothing but the in the direction of the electric field potential decreases. So electric field they given E equal to Ax plus B I cap. So here I cap they given along the x direction, that's why I took the x component only. Okay, na? So now integrate this one. So integration from 1 to 2, they are asking the V1 minus x equal to 1 and x equal to minus 1 to 2 they are asking. So 1 to 2 equal to minus integration from x1 to x2 E dot dx. So integration dv ka integration is v, upper limit of 2 and lower limit is v2 minus v1 we will get equal to minus of E value is how much, Ax plus B I cap, x direction only na, Ax plus B dot and dx is there. And whenever x1 is at 1 and potential is at the v1, okay, v1 and x1 equal to minus 5, that means we have to integrate from the x equal to 1 to the minus 5, 1 to the minus 5. Okay, so then minus sign send this side, it will become v2 minus v1 will become v1 minus v2, otherwise here take the minus as common and cut it. So v1 minus v2. So Ax ka integration and B ka integration we have to Ax into dx, A is a constant, x ka integration x square by 2, upper limit minus 5, lower limit 1, plus B into dx, B is a constant, integration of dx ka value is x lower, upper limit is minus 5, lower limit is 1. So V1 minus V2 equal to the A value is 20, 2 is a constant, write down outside. So 20 by 2 into x square, upper limit minus 5 whole square 25 minus lower limit 1 square means 1 square plus B value is how much, 10, they given 10 into x value, upper limit minus 5 minus of lower limit 1. Okay, substitute. Now V1 minus V2 equal to 20 by 2 is nothing but the 10, no, 25 minus 1 is the 24, 24 into 10 240, minus 5 minus 1 minus 6, minus 6 into 10 minus 60, so minus 60, 240 minus 60 equal to 180 volt. So the potential difference V1 minus V2 is the 180 volt. Okay, remember this formula. Okay, na? So next question is the three charges Q plus Q and plus Q, capital Q, small plus Q are placed at the vertices of a right angle isosceles triangle as shown. The diagram also given in this way. Okay, either plus Q, small plus Q, either capital Q. Configuration is the net electrostatic energy of the configuration is 0. If the value of Q is net electrostatic energy equal to 0, then value of Q we have to find. Okay, I am redrawing the diagram here. So here I am redrawing here plus Q, Q. If this is the given right angle isosceles triangle, so both the two sides are equal. So this is L, then this is also L. Then right angle triangle, from that we can get this one root 2L. So here how many charges are there? 3 charges are there. How many number of pairs will be formed? Equal to n into n minus 1 by 2. So 3 into 3 minus 1 by 2. So 3 minus 1 is 2, 2 will be cancelled, 3 pairs will be formed. That means we have to find the potential energy between these two. Potential energy between these two. Potential energy between these two. So this is the first, second, third. So now the potential energy of the system. The potential energy of the system is potential energy between these two. Formula is K Q1 Q2 by R. K Q1 Q2 by R. Q into Q by length between this one is L plus potential energy between these two. K into Q square by distance between them is L plus K into Q by the distance between these two is root 2L. So this is the electrostatic potential energy of the system, but the given the net electrostatic energy of the configuration or system is 0. Now this one equate to the 0. Now in this case KQ by L is the common in every term. So kq by L I am taking common there. Here q is there, either small q is there, either q by root 2 is there. Now kq by L send, that side it will become 0. In this case we have the capital Q plus capital Q by root 2 is in a capital Q common, 1 plus 1 by root 2 plus small q equal to 0. Now here LCM take capital Q into root 2 plus 1 by root 2 we will get, plus small q send, that's a minus q, and q equal to how much we will get, root 2 will come this side, minus root 2 into q by this root 2 plus 1 become denominator root 2 plus 1. So the charge they are asking the value of q, that is minus root 2 q by root 2 plus 1. D option is the right answer. In this way we have to solve the problems. Okay, see the next question, fourth question. 4 equal point charges q each are placed in the xy plane with the given the coordinates 0, 2, 4, 2, 4, minus 2, 0, minus 2. The work required to put a fifth charge q at the origin of the coordinate system will be, okay, to keep the one more fifth charge at the origin, what is the work required? Okay, now they are asking. Okay, now according to that question, this diagram not given, I am drawing diagram. See now, this is the y-axis, this one is the x-axis. Now this is the origin. First charge is at the 0, 2, 0, 2. Here first charge q. Second charge is at the 4, 2. Here 4, x is 4, y is 2. So x is 4, y equal to 4, 2. Either the charge is q. And the next one is the 4, minus 2, 4, minus 2. Here the charge is q. And the next charge is 0, minus 2, 0, minus 2. Here 4 charges are here, origin. And the next we have to bring the one more charge, fifth charge to the origin. So that means what is the potential at the origin due to these 4 charges we have to find. So potential due to the first charge here, potential due to the second charge here, potential due to the third charge here, potential due to the fourth charge here. Okay na? So we have to find the potential due to these 4 charges at the origin. Okay, potential ka formula already we know, potential equal to the V equal to K cube by R. So now potential at the origin due to the 4 charges, V equal to V1 plus V2 plus V3 plus V4. Okay na? Potential at the origin due to the 4 charges equal to the V equal to V1 plus V2 plus V3 plus V4. Potential. So potential formula K cube by R. So total potential at the origin V0, I am taking, okay, V0 equal to the V1 value due to this one, K, Q is the charge is Q, by distance from this charge to the origin, Y coordinate 2 only. So by 2 plus due to this charge, this charge I am taking, okay na? From this charge to this charge potential, so K, Q is the charge is the Q, and the distance from here to here is the 2 plus only we have to take scalar quantity, okay, 2 plus potential due to this charge and potential due to this charge we have to find. So distance from here to here, this distance is 4 and this distance is 2. So to get this one from the right angle triangle, so this is square 16 plus this is square 4 equal to this is square OQ square. Now OQ equal to how much we will get, square root of 20. That means distance from here to here 20, distance from here to here also 20 only. So now Q is the charge by distance from here to here is a root 20, here to here also root 20. So KQ by root 20 plus KQ by root 20. All the charges, all 4 point charges have the same charge, 4 points have the same charge Q only. So now KQ I am taking common, so 1 by 2 plus 1 by 2 plus 1 by root 20 plus 1 by root 20. And next KQ into 1 by 2 plus 1 by 2 is a 1 by root 20 plus 1 by root 20, 2 by root 20. 2 by root 20 we can write as 4 into 5 and 4 will come, 2 will come out, so 2 root 5. So now V not equal to the, at the origin the total potential equal to the 2 will be cancelled out. I am going to write this one, 1 plus 2 will be cancelled out, root 5 volts. This much of potential at the origin. Okay, and the next this much of potential is there. To against this potential we have to bring one charge to here. We have to do some work, that work equal to the W equal to the Q into V. We are bringing the Q charge to the origin. Already at the origin we have the V0 potential. Now Q into V0 value is KQ into direct step I am writing here 1 plus 1 by root 5 only. I am not simplifying anything. Why? Because options also 1 plus 1 by root 5 only there. So now Q into KQ square into 1 plus 1 by root 5 joules, work done equal to the, but here K value we have to write, K value is 1 by 4 pi epsilon, then answer is Q square by 4 pi epsilon naught into 1 plus 1 by root 5. So Q square by 4 pi epsilon, D option is the right answer. In this way we have to solve the problem. So first we have to find the potential at the origin, okay, potential at the origin, okay, due to these 4 point charges, and next work required to put a fifth charge at the origin. So work required equal to W equal to Q into potential at the origin. So substitute, we will get the answer. Next see the question number 5. A uniform electric field pointing in positive x direction. So electric field ka direction is positive x direction. Let A be the origin, okay, exist in the region, okay, x direction may exist. Let A be the origin, A is at the origin, okay. B be the point on the x axis at the x equal to plus 1 centimeter, and C be the point on the y axis at a y equal to plus 1 centimeter. Then the potential at the points A, B, C satisfies. What is the condition it will satisfy? I am drawing the diagram. See now. First A is at the origin, okay. B is at x equal to plus 1 centimeter distance, B is here. Now C is at the y equal to plus 1 centimeter, C is at this point, and electric field direction is in the positive x direction, electric field is going in this direction. Okay, now this is the vertical line, okay. So that means the points on these vertical lines have the same potential. So now this A is at the origin and C is at the y equal to plus 1 centimeter, x, y coordinates for the C is nothing but the 0, 1 only. So now A and C are on the same vertical line, so then both have the same potential VA and VC. These are the equipotentials. And the next B is at the 1 centimeter from the origin, so the potential decreases in the direction of the electric field. So that means from A to B potential decreased, that means A is the high potential, B is the low potential, VA is greater than the VB. So which condition is satisfying? See now, VA equal to VC, not given here, VA is greater than VB, VA is greater than VB, B option is the right answer, okay. So if we draw the vertical line to this perpendicular line drawn to this electric field, then that perpendicular lines indicate the equipotential surfaces. Already in the previous question I said to you, that means electric field is perpendicular to the equipotential surfaces. So A and C are equipotential surfaces, and if you are moving in the direction of the electric field, potential decreases. So at the A potential more, at the B potential is less. From that, B option is the right option. Now come to see the sixth question. Figure shows charge versus voltage. Okay, now the given figure, this one, on y axis they are taking the charge in terms of the microcoulombs, and x axis we are taking the voltage. Okay, for series and parallel combination of two given capacitors, the capacitance are, okay, this graph is for the series and parallel combination. So based on this graph, easy questions, mains level question, this one. So once you see this graph, this is the A and this one is the B, and y axis we have the charge and x axis we have the voltage. Now see, from B to A, slope increased, okay na, slope increased means slope of the A is greater than the slope of the B. Why I am finding the slope means, once you see now, the charge and the voltage potential ka relationship is Q equal to C into V. That means here if we draw the graph between the Q and V, then V will show the capacitance will indicate the slope of this one. Okay na? Now OA ka slope is more than the OB slope, that means capacitance of this A is greater than the capacitance of the B, capacitance of A is greater than the capacitance of the B. Next, when the capacitance is more, in parallel combination or series combination, that means in the parallel combination capacitance equal to C1 plus C2 plus and so on, but in the series combination, so 1 by Cs equal to the 1 by C1 plus 1 by C2 plus and so on. That means in the parallel combination capacitance increases, in the series combination capacitance decreases. So slope is more means that is parallel combination, slope is less means that is the series combination. Okay na? So for parallel combination, for A this is the parallel combination, for B this is the series combination. Now find out the slope. Okay, so the slope of A will give the parallel combination of the capacitance. So parallel combination of the capacitance equal to the C1 plus C2 equal to the two capacitors they given us. So C1 plus C2 equal to the, here slope of this one, what is the slope, y component by the x component, coordinate by the x coordinate we will take now from here to here, y, that is 500 microcoulombs, 500 microcoulombs. By voltage is how much, x component 10, from that we will get the 50 microfarads. So the slope of A will give the parallel combination of the capacitance, that is equal to 50 microcoulombs, microfarads. Okay, Cp we got. And next come to see the slope of the B we have to find. So slope of this one is nothing but y coordinate is from here to here 80 microcoulombs, 80 microcoulombs by voltage is the 10. So from that we are getting 88 microfarads. So two capacitors in parallel combination, then resultant equal to C1 plus C2 equal to 50 microfarads, and the two capacitors are connected in the series, then equivalent series capacitance equal to C1 into C2 by C1 plus C2 equal to the 8 microfarads we got. Okay, from this once you see this one, C1 into C2 by C1 plus C2, already we found C1 plus C2 equal to how much, 50 microfarad. Substitute 50 into 8 equal to 400 microfarad. So C1 C2 value is 400 microfarads, C1 plus C2 is 50 microfarads. We have the two unknowns, so two equations we have, we can find it very easily from the mathematics. Use this is the homework to you. We know the C1 C2 value, product of C1 C2 and sum of C1 C2 value. Find the C1 C2 values. We will get the values 10 microfarads and 40 microfarads. D option is the right answer. This simplify these two equations and you will get the answer. That is the homework to you. Next come to see the next question. The charge on a capacitor plate in a circuit as a function of time as shown in the figure. Okay. So now either Q and T on y-axis they took the charge in terms of the microcoulombs and in the x-axis they took the time, seconds. Okay, what is the value of the current at t equal to the 4 seconds? At t equal to the 4 seconds we have to find. So now current passing, current ka formula we have to write first. I equal to the dq by dt or q equal to the it we will write now. So if we draw the graph between the charge and the time, I will give the current we will get from the slope. Okay, if we find the slope of this graph, we will get the current at that time. Okay, they are asking the at 4 seconds what is the value of the current. At 4 seconds, you know, at this place we have to find the current. So at this place, this graph is parallel to the time axis. Okay, now so then slope of this graph is nothing but the 0. So slope equal to the 0. Slope will give the current. Okay, now slope will give the current. So slope equal to 0 means so current also equal to the 0. No, current equal to the 0. This is also mains question. Don't underestimate the questions. Okay, see the next question, 8th question. A capacitor with capacitance 5 microfarad, capacitance given C equal to the 5 microfarads is charged to 5 microcoulomb. Charge they given 5 microcoulombs. If the plates are pulled apart to reduce the capacitance, 2 microfarads. So C1 is 2 and C2 equal to 2 microfarads. How much work is done? So that means to reduce the capacitance from 5 microfarads to the 2 microfarads, how much work we have to done. So to get this one, initially what is the energy we have to find after pulling, then how much energy is that we have to find. So energy stored in the capacitance formula you have to remember U equal to half QV or half Q square by C. So here they given charge and capacitance, now we have to use half Q square by C formula. Initially the charge is the 5 micro, both the cases charge is the common only but capacitance are changing here. So initially half Q square by C1 and finally half Q square by C2, capacitances are changed. So now what the work done to reduce the capacitance value from 5 microfarads to the 2 microfarads, the work done equal to the change in the potential energy. Okay, now how much work we have to find, So now final is half Q square by C2, initially is half Q square by C1, half Q square is a common here, 1 by C2 minus 1 by C1, half into Q value, charge value is 5 microcoulombs. So 5 into 10 power minus 6 whole square into 1 by C2 value is 2 microfarads, 1 by 2 into 10 power minus 6 minus C1 value is 5 microfarads, so 1 by 5 into 10 power minus 6. See the simplification, 1 by 2 into 5 into 10 power minus 6 whole square, 5 into 5 into 10 power minus 6 whole square means 10 power minus 12. In this case 10 power minus 6 is common in the denominator, so 10 power minus 6 I am taking as a common, remaining is 1 by 2 minus 1 by 5. So now here 1 by 2 into 5 into 5 25, 10 power minus 12 by 10 power minus 6 is 10 power minus 6, 1 by 2 minus 1 by 5, take the LCM and simplify, we will get the 3 by 10. So now 25 into 3, 75 by 2 into 10, 20 into 10 power minus 6. 75 by 20 is 3.75 into 10 power minus 6 joules. So work done equal to the 3.75 into 10 power minus 6 joules. So we have the energy stored in the capacitor, we have the two formulas. So based on the given data, use the formula. Here the given charge and coulomb, that's why I am using this formula. And next see, very important question, this question asked in the last year mains exam. In the circuit shown, find C. Okay, this is C value we have to find. If the effective capacitance of the whole circuit to be 0.5 microfarad, this total circuit ka capacitance, effective capacitance is 0.5 microfarads. All values in the circuit are in microfarads. Either 2 given means 2 microfarad, 2 microfarad, 2 microfarad, 1 microfarad, 2 microfarad, 2 microfarad, 2 microfarad. Okay, now these are the values. This is the circuit they given. They are asking to find the C value we have to find. So we have to reduce the circuit and we have to find. So first see now, I am redrawing the same diagram here. So from this diagram see, these two are in the series combination. 2 are in the series combination. So series combination may 1 by C1 into C2 by C1 plus C2. Two resistors are connected in the series combination. Sorry, capacitors. So equivalent capacitance equal to C1 C2 by C1 plus C2. So 2. So 2 into 2 by 2 plus 2 equal to 1 we will get. So equivalent capacitance of this 2 is a 1. And the next here also see, these two are connected in the parallel. So parallel combination Cp equal to the C1 plus C2. Okay, if two capacitors are connected in the parallel combination, then equivalent capacitance equal to sum of that capacitance. These two are connected in the parallel, so for 2 plus 2 equal to 4 microfarads. Okay, I am rearranging this one. So redrawing, so C is there, C2 is there, 2, okay. At the place of this 2 I am writing this one. The equivalent resistance of this 2 is nothing but the 1, okay, 1 microfarad, and here 1 is there, so 1 microfarad. This one completed. Now come to this one. This 2 microfarad is there, 2 is there. The equivalent resistance of the equivalent capacitance of this 2 is nothing but the 4 microfarads, 4 microfarads. Okay, after this circuit come to here. Okay, next here see, these two are in the parallel combination. So equivalent capacitance is 1 plus 1, 2. So I am redrawing here, C is there, 2 is there, and equivalent resistance of this 2 is nothing but the 2. Okay, 1 plus 1, 2. So 2 I am writing here. And next these two are in the series combination. Okay, then equivalent resistance equal to 2 into 4 by 2 plus 4. Then we will get this value. How much? 2 into 4 by 2 plus 4, 4 by 3 we will get. So equivalent capacitance of this tree is nothing but the 4 by 3. Okay, now from this we got this one. And next come to see here. So C is there, C. These two are in the series. So say these two are in the series combination. 2 into 2 by 2 plus 2, 1. So the equivalent capacitance is 1. And next what is here? 4 by 3 is there, 4 by 3. Okay, now next here see now. These two are in the parallel combination. Okay, na? These two are in the parallel combination. This is the 4 by 3. 4 by 3. These two are in the parallel. So equivalent capacitance of this 2 is nothing but the 1 plus 4 by 3. 1 plus 4 by 3 is nothing but 7 by 3 microfarads. Now this value we got. Okay, this one. Okay, finally we will get here C, and here we will get the 7 by 3 microfarads. Okay, this is the B point. And okay, effective resistance capacitance between the A and B is the 0.5. So effective capacitance between the A and B, these two capacitors are connected in the series now. So C into 7 by 3 by C plus 7 by 3 equivalent capacitance. So the effective capacitance between the A and B they given 0.5. So CAB equal to 0.5 equal to the, so either 7C by 3 we will get here, after LCM 3C plus 7 by 3 we will get, denominators 3 and 3 will be cancelled, in the numerator we will get 7C, here we will get the 3C plus 7, cross multiplication we have to do, 0.5 into 3 1.5C plus 0.5 into 7 3.5 equal to 7C, 1.5C sent that side it will become 5.5C, 7C minus 1.5C, 5.5C equal to 3.5. So now C equal to 3.5 by 5.5. Then it is equal to the 7 by 11 microfarads. So 7 by 11 microfarads. Whenever you are solving this problem, do it carefully. It will take some more time, but easy problem. You can get it very easily, 4 marks. Next question, see now. In the figure shown, after the switch S is turned from position A to position B, the energy dissipated in the circuit in terms of the capacitance C and the total charge Q is. Okay, now in terms of the C and Q we have to find. So initially, see now, switch is A position, switch is connected to the A position, then how much energy is there? So switch is connected to the A position, then energy stored in the capacitor equal to U1 equal to the half C V square plus E square, half C E square. So now this totally fully charged now. After fully charged, now switch is connected to the B. Okay, now how much this charged means Q equal to C into V. V is nothing but the E there. So this capacitor is fully charged now. How much charged means Q equal to C. Now this one is connected to the C. Okay, 3C na. So then discharge takes place and it will come to the common potential. What is the common potential? So why? Because after connecting to the B, how much energy is there? That we have to find. To find out the energy, we have the formula. Either two capacitors are connected na. So energy equal to half into C equivalent into Vc square. Vc is nothing but the common potential. That means here this will be discharges and the common potential. Whenever it comes to the steady state, then common potential equal to the total charge. If initially this does not have any charge, now it has the fully charged to C, then this will be discharged. And what is the charge? Is the total charge C. This will lose and this will gain the charge, but total charge is conserved here. So total charge of this system is nothing but the C by total capacitance. These two capacitors are connected parallel. So C plus 3C equal to 4C. Now common potential equal to CC will be cancelled, E by 4. Common potential is the E by 4 and total capacitance equal to the 4C. Then energy of the system after connecting the switch to the B. So U2 equal to half into C equivalent into Vc square, half into C equivalent equal to how much? C plus 3C, 4C, and the common potential is how much? E by 4, E by 4 whole square. Then from that we are getting the 1 by 8 C E square. Okay, that means whenever switch is connected to A, energy is half C square, energy stored, and whenever it connected to the B, the energy stored is the 1 by 8 C square. So something energy has dissipated. How much energy is dissipated means energy dissipated equal to the initial energy minus final energy. So initial energy is the half C square, final energy is the 1 by 8 C square. From that we will get the 3 by 8 C square. But they are asking the energy dissipated in terms of the capacitor C and the total charge Q. So Q equal to C, E equal to, from this what will we get? E equal to the Q by C. At the place of E, substitute the Q by C. So Q by C whole square. After simplification we are getting the energy dissipated is 3 by 8 Q square by C. So option D is the right answer. In this way you have to solve all the problems. All these problems are previous year's questions only. Practice more and more previous year's questions. You will get the score, you will get score very easily, 120 plus or 160 plus also. Thank you.